All right, hopefully you've had a chance to try this problem. This one is a little different in that it has a 99% confidence interval instead of a 95% confidence interval, but the handy list of magic z-scores from the previous document should help you with that. The thing that's most important, of course, is to make sure we are clear on what we're estimating. And so in this case, P is the proportion of all college students. What was that? Too many things beeping at me. All college students, I guess it's all American college students, who would answer yes to this question if we could ask them all. So the main thing there is that P is a proportion in the population, so it's not measurable, which is why we're using a confidence interval to estimate it. What we call the point estimate, that's our sample proportion, so that's what we call P hat. That is the exact same thing that P is, but instead of proportion of all college students, which is not knowable, we're talking about the proportion of the college students who we surveyed, which is knowable. There were 76 of them. And so as usual, we say when we see proportion of something, that's telling us what to divide by. Proportion of the American college students, that's what we're dividing by. And then we have the part of them that said yes, which is 42. So these proportions are always the part divided by the whole. 42 over 76 on my calculator is about 0.55, so about 55%. The next thing that we need is the standard error. Remember that the visual picture that I want you to have is we have the normal curve. We're used to drawing the center and our 3 tick marks in each direction. The size of the tick marks, the distance between the tick marks is the standard error. So that's what we're finding here. The formula for that is we do 0.55 times 1 minus 0.55, and then divide by the sample size, and all of that is under the square root. And so on some calculators, it's easiest to do that as 3 separate steps. Do the multiplication, divide by 76, then take the square root of the answer. But in this case, that is 0.057. And so that's how far apart these tick marks are going to be on the picture. Now, if we want to capture 99% of the possible P hats, we would need to go all the way out here beyond 2 tick marks in each direction. The number of tick marks we need to go out specifically is 2.58 tick marks in each direction in order to capture 99%. And that, like I said, there was a link to a video in the last document that shows you where those numbers come from, but we don't really care. We'll always have those available to us, and we just want to make sure we understand what we're looking at. So if you know it's 2.58 tick marks in either direction, and you know each tick mark is this big, then you know how far to go out in each direction. It's just the magic z-score, 2.58, times the size of 1 tick mark, 0.057. We multiply those two things together, we get approximately 0.147. So the upper and lower limits of the interval are going to be to take our point estimate, 0.55, and subtract the margin of error. That'll be our lower estimate. And then our upper estimate will be 0.55 plus the margin of error. And so we're 99% sure that the true value of P, so the true proportion of all college students who would answer yes to this question, is between 0.403 and 0.697. So notice that in terms of percentages, that's between about 40% and 70%. And so that does not narrow it down very much at all. And that illustrates the fact, well, two things really. One thing is that having a sample size of 76 is not very many. And so we're never going to be able to make a very convincing estimate when we only have 76 people in our sample. And so it's not that surprising that the range is so wide. Because I'm using a 99% confidence interval, I want to say something that I'm 99% sure is true, which means I have a very wide interval, because the only way to be very, very confident in what I'm saying is to say very little. So saying the proportion is between 40% and 70% says very little, but I can be 99% sure that's right. As a follow-up question, it asks here, if someone insists that our results prove the majority of all college students would say yes, well, it doesn't. Our point estimate looks like it says 55%, and it does. And so you could say, well, that means the majority of all college students would answer yes, but that's not true. The majority of the students we asked said yes, but when we estimate the range of values, starting with the data that we have, all we can say is between 40% and 70% would say yes. And so we certainly are not 99% sure that the true proportion P is greater than 50%. Far from it. It could very easily be less than 50%. So for you, what you're supposed to do to turn in for me is do the B part. I'll put it on the screen here. So if you'd like to just stop the video and have this available, you can do that. And I want you just to fill in all the parts here that you see for this part of the problem. You don't have to rewrite the problem if you don't want, but I would like you to label the pieces so I can see them easily. Step 1, step 2, step 3, step 4, step 5 on a piece of paper, and take a picture of it and upload it to D2L.